Thank you so much, Jørn. And on the agenda today, I put here on the right, very short. I'm going to try to explain to you what is a platform, what do we mean by this term, and of course dive into what are the challenges with configuration platforms and the need to have this agnostic platforms that I'm going to talk about. So what we work with at Configit is called configuration lifecycle management. I assume and expect that you have heard about this before. Basically, what we are trying to achieve is to align various functions in organizations, typically between engineering and sales, so that we can get a fully transparent flow of data from customer needs to how you're going to manufacture and deliver the products. And what we see when we go and engage with customers is that they traditionally have a number of systems in play. They have large enterprise systems such as PLM systems for engineering. The sales organization will use another set of systems, CRM systems, CPQ systems for managing the customers and the sales processes. And they also have manufacturing systems, ERP, and then around those there will also often be a number of homegrown legacy systems that each solve a narrow need in some specific part of the organization. And the challenge, of course, is that when you need to get information that is aligned from early design to sales to manufacturing, then these systems needs to be aligned. And they all have their own configuration logic. When we deal with configurable products, if it's PLM, they will have variant management modules, features and rules. Same thing for sales systems, CPQ systems, configure pricing quoting. They definitely will have some type of configuration logic. And ERP systems also, if it's SAP, for example, it has the variant configurator. And so they each have their own view tailored to each of the perspectives, whether it's engineering, sales, or manufacturing. And CLM is really about bringing these different views into one combined, consistent view so that you get the combined effect of all these types of rules. You might have technical engineering rules, you might have commercial rules and packaging and customer requirements and that type of things, and you might have logistics and manufacturing rules, and you need to bring it all together in this single source of truth. And what I would like to spend the time on today is to explain a little bit more on how this is achieved and how you can achieve this and the challenges that you might encounter. Now, before this, I would like to try to put some words on what is a platform. When we talk about software platforms, what is it really we mean about that? And I've tried to collect some of the properties of a piece of software for it to qualify as a platform. So the first one is, well, it has to be open, it has to be extensible, it has to be customizable, open APIs, well documented, stable, scalable. The scalability is also in terms of making sure that the system can adapt to increased needs when you want to roll it out to other business units or maybe even outside of the organization. The platform will have to be able to scale and support that. Often you also expect a ecosystem of resources. You expect that there are others that can help you build on the platform, other partners, consultants. It might be other resources in terms of applications that have been built specifically for the application. And then a platform typically is unique by bringing value by connecting different data, different processes, different tools. That's how a platform brings value. And these properties are all, you could say, generic. They don't necessarily have to do with configuration as such. But when it comes to a platform for handling configurable products, what we believe to be a very important property is that it has to be able to consume data that comes from many different sources. You have just seen the picture I drew with ERP and PLM and the other ones. they each have rule sets in there, and they have taken years to develop. And we are not suggesting that you redo that at all. Rather, we suggest that you can import those rule sets into the platform, and thereby providing access to all the consumers on the platform to that rule set. So the question, of course, is how do we achieve this? And before diving into this, I put some logos on here, basically trying to indicate typical platforms. These are all platforms according to the notion of the first 4 items. But the question is, how do you unify these different rule sets? How do you bring them together in this center? And if you dig into these systems, what you'll find is that the way you express the rules, the way you construct these configuration models is actually very dramatically across the different systems. So I put here 4 different examples of how a typical rule could look like. And these are not particularly complex or difficult, but it's just to illustrate. For example, in a barn PCF configurator, it is sequential code. You cannot tell that, but it is. There are little messages coming out. In SAP, they have a very specific way to write rules. There are 4 or 5 different rule types. They each have their own properties and a lot of stuff going on here about objects and restrictions and inferences. If you look at the lower part, it's a Salesforce CPQ, how you can express a dependency between some choice and some other choice. In this case, it's an exclusion. And the screenshot at the left here, lower left, is a legacy tool that also is used to define rules. So how do we combine all this? It doesn't seem that simple. And this is where we have introduced Ace as a platform that exactly tries to solve this problem. Ace is basically consists of 2 major modules. It's the Ace model module, where you can define the configuration models on its own. You will find many tech sessions on that, how to create models and do that, but it can also import data from other sources. So for example, some of the types of rules that we just have seen. And then there's the Ace configure, where you can access that data through a standard web API. And the cool thing here is that the consuming applications wouldn't know what source they came from. So the API, whether it's an SAP configuration model, whether it's a Configit configuration model, whether it's a legacy configuration model, the API is exactly the same. And the same application can be used to configure all 3 different configuration models, and the application wouldn't know the difference. So if I had to try to illustrate this a little bit more, we can import data, and the typical scenarios are the ones shown here. We can import data from SAP, the variant configuration rules. We can translate those to our Ace rule set. We can import, for example, rules from PLM systems. It could be PTC Windchill, could be ARAS. That is typically engineering rules that are still being maintained in the PLM. So we are not suggesting that the maintenance is being moved. Rather, maybe that you decide to, on a daily or continuous way, you import these rules, and then in Ace you would then maybe add the commercial rules on top of them, and then compile the whole thing into one representation, and that is your single source of truth. But the rule maintenance can continue to be in the PLM system. We also have examples where we import rules from legacy systems, and for some of these connections we have standard connectors. We have a standard connector to SAP. We have also for ARAS, and have also done it a number of times for PTC Windchill. In other cases, for those where it's a legacy application, well, somebody will have to write that converter to how the rules as it's being expressed in that particular system maps to the rules in Ace. And then when you have imported the rules, maybe combined multiple models, maybe added additional rules in Ace, then we expose that result. And the way we do that is that we have a service for exposing the configuration logic, and we have another service for exposing pricing information. We also have services for the bill of material. And those are open, well-defined, stable APIs that you use in your application to build that application. And the applications can be very different. It can be things like a public website. It can be maybe an offline, online application. It could be something like running on an iPad. It could be maybe a dealer management system that integrates to these services. It could be maybe from Salesforce CPQ that integrates to a configuration application that runs on these services, or it could be from within engineering PLM systems where you need to author, say, bill of material logic and need to have access to the configuration models that way. I want to make one point here. I've seen recently that some talk about this concept of model once, configure everywhere. That is the concept of bringing all the models into one and the same authoring environment. And we tend to say that that's too hard. We would rather keep the authoring in whatever system it is relevant to author it, but then have a single source of truth when it comes to the consumption. So we call, or you could, instead of model once, configure everywhere, you could think of that as model everywhere, or model anywhere or configure everywhere. But the point is that we can keep the data being maintained in whatever systems that you like and still bring it together to achieve this single source of truth. Another point I would like to make, this is a tech talk, so I would like to make it a little bit technical. Ace is based on a very precise semantic of what a rule means. And this is important. The moment you want to move a rule from one system to another, you have to make sure that it gets interpreted exactly the same way. So you have to have very precise understanding of what the meaning of the rule is. That's what we call the semantics. And Ace uses a very simple semantic and is based on what we call, not we call, but what is called declarative rules. And a declarative rule is a way of writing rules that expresses a relationship versus defining some steps or operations to perform. So a rule that expresses a relationship basically says, there is this relationship and the configuration has to make sure that it's always is satisfied. That's basically what our rules would say. I'll show you an example in a moment. And one point is that if you want to have guidance to the user so that he gets guided to what choices he can make in the configuration process, you must have a model that is only consisting of declarative rules. The moment you start to introduce procedural rules, you can no longer guarantee this type of guidance. So here's an example. It's a very, very, very simple example. It only has 3 configuration parameters: valve type, number of evaporators, and number of outputs. You can see the choices you can choose for them. Circuit, coil, or ETE is the choices for the valve type. The number of evaporators is a number from 1 to 3, and number of outputs is a number from 0 to 3. And there's only one rule. And the rule says that if you choose valve type to be circuit, then you must have 1 output, otherwise the number of outputs must be equal to the number of evaporators. So, and I said that when you choose valve type, but of course you don't have to start with valve type. You can choose any value for any of these 3 configuration parameters in any order. So you could, for example, choose that you would like to have number of outputs to be 3. And you can look at this rule and you can start understanding what does that mean. So number of outputs is 3. Well, it means it's not 1. So from that, you can deduce that you cannot get circuit because that would break this rule. If you chose circuit, it says that you must have 1 and you chose 3. So you cannot have circuit. And since you cannot have circuit, you also can deduce that then you fall into the else part. And that means that your number of evaporators will then have to be equal to number of outputs, which you just set to 3. So your number of evaporators will also be 3. This is a logical deduction of a rule, and the point of this example is to illustrate that the deduction flows both ways, even though in traditional programming you would sort of look at the if part and then you would continue to the then part if it evaluated to true. That's not how it is with declarative modeling. You basically just put up a relationship between the variables, and the configuration engine will have to guide you to how you can select these configuration parameters to satisfy all the rules. So our configuration API is completely agnostic to where the rules come from. And I will show you an example of how this will look like in a second. The way this API works is that the configuration application will basically call our service. It will call with the service that it would like to call, the configure, and it will call with some information about what we call the package, which is basically the data set. And it will then send over a payload as a JSON object. So this payload I'll show you in a second, but it basically specifies what product would I like to configure and what are the selections I have chosen already. And then the service will return back a payload, and that payload will tell you for all the configuration parameters in the model, what are the choices you can make. So it will be all the information the configuration application would need in order to build up a UI that guides the user. So let me show you how that looks like in a little example. We had this model shown on the left here, and you can see, or we can try out what happens if we send over this choice of selecting 3 outputs. We will basically say, here is a package, and we will specify the product. Let's call it Valve, and we will specify what assignments the user has done. And in this case, the number of outputs variable has been selected to the value 3. And with that information, the configuration service will respond. It will respond with information about all the variables, all the configuration parameters in the model. I've just selected one of them, the valve type, and that's the one you could see we deduced a moment ago. It couldn't be circuit, and what you can tell from the return, you can see it returns an entry for circuit, coil, and ETE. Those are the 3 values that we had over here, and it will specify that circuit is unavailable. It will specify that coil is selected by default, and it will specify that ETE is available. So you cannot get circuit. It selected the coil as a default selection. You could change that selection to be the ETE if you like to. I have left out a little bit of detail here, but this is the core of what it returns. What is important here is that in this dialogue between the application and the API, you will notice that it has no mention of rules at all. It doesn't, the application cannot tell how the configuration came to this conclusion. And the fact that it had this rule, or if it had been written in a completely different way, it could have come from a completely different system and had just been imported, the dialogue here would have been exactly the same. So this allows us to build applications that can be used across many different configuration models coming from many different systems in the back. And that gives us an enormous flexibility. And you can imagine an organization that maybe buys another company and then they bring in another configuration system. All they have to do is figure out how to map those configuration models to the Configit semantics. And with that mapping, you can put them on Ace and you can reuse the same applications as you've been using for your existing products. Oh yeah, so this was how the UI could look like if you updated it based on the result you got here. So that was really what I had in mind to talk about today. As I try to point out, the important aspect here is this ability to combine data from multiple sources. And you can of course say, well, Ace can do this if you decide that one of the existing enterprise systems should be your single source of truth when it comes to configuration data. Well, you would have to see whether this is even possible. Can you map all your data to SAP models, for example, if you choose to put everything in SAP? And what we have experienced is that is very, very difficult. Also, the fact that you use a single common set of APIs to build the suite of applications that you need is making it super efficient to add new capabilities and new applications. So with that, I hope we have a little bit of time to take some questions. And otherwise, I will just say thank you. So questions, please.
Not so fast, Henrik. There's one question says, what is involved to import models, for example, from legacy configuration solutions?
Yeah, so what's involved if you want to do this mapping from a legacy system? The important part is to understand, as I said, what is the semantic of that model, and that means how does it behave? Because it's absolutely essential that the behavior when you put it into Ace is the same as the behavior as you would have found it in the legacy system. Now, this can be more or less straightforward to determine. Some have built fairly nice applications where the rules are expressed in a standard formalized way. Then you just need to map those to the Ace rules. But of course, we also see situations where the rules maybe even have been coded up as traditional programming code within the application. And then it becomes more of a analysis to dig those rules out. And I think in that scenario, you would typically like to recreate them from scratch in Ace. But if you do have an application where the rules sits in a database or they sit in some textual format, then it is pretty common and not a huge task to write a mapping, a software tool that takes that rule data and maps it to the standard input format that we can accept.
Interesting. Yeah, that makes a lot of sense. So there's another question I have here. So it says, what kind of data can be imported from SAP to Ace?
Yeah, so we support a pretty wide set of data when it comes to the configuring and pricing. We support most, if not almost all, the configuration constructs in SAP, and we also support a wide range of the pricing constructs that you can define in SAP. We also can import the bill of material as being defined in the SAP system. And this is a good example where we, for example, for pricing, we need to be able to execute the pricing logic because, of course, when you're configuring, you would also like to see the price, but the price data is being mastered in SAP. So we will typically set up an extraction of that data, maybe every night, and publish that to Ace, and then it will be readily available as part of this pricing service. Yeah, so in terms of what we handle there, we have a long list of the functionalities that we do support. SAP is very, very flexible. So so of course there are constructs that we may not support, but we do have a very, very complex price logic that we execute.
There's another question coming in, perfectly fits, so that maybe you can extend your answer towards Windchill and errors. So it's basically the same question. What kind of data rules can be imported from Windchill and errors?
Yeah, so unfortunately, I'm not really the expert there. We do not have completely out-of-the-box standard integrations to those two systems. We have on our what we call the SDK. We have some sample code of importing the rules from errors, and I know a lot of our customers import rules from PTC Windchill. The way I understand Windchill is that the syntax and the capabilities in Windchill is pretty limited, so it's very simple to map those to what we have in Ace, and the same goes for ours. Both have a rule syntax and a rule definition that is very easy to handle. But we do not have that as a productized integration at this point.
All right, that makes sense. Thank you. So there's another question that says, I just read it up here. Rather new is the product cloud, where product data is stored. How to incorporate this with CM? CM, I'm not quite sure what it means. Do you know what it is? Otherwise, the person who has asked the question can refine.
Yeah. So the cloud is opening up a number of new possibilities, and I have not touched upon that in this presentation, but of course we are gonna have an Ace in the cloud offering very soon, and that allows you to post these configuration models on a cloud service, and thereby you could also make them readily accessible from, say, resellers. And this is something where I think we will start to see applications. So for example, some of these applications shown at the bottom on the screen here, you could imagine a CPQ applications where you build up your quotations based on data from different vendors. You might have a system integrator who needs different components from different sub-suppliers, and he would like to build up a quote that consists of those. And if those sub-suppliers all put their products on, say, the Ace platform, then it would be very trivial to build up such an application. It will basically search in one catalog, find the products from one vendor, including pricing, and you can put a line on the quote based on that. And then it could search in another catalog for another product, configure that, and price that, and put that as a separate line. And that opens up a much more open way of collaborating and combining data. And the nice thing is that the services for configuration and pricing, they actually don't reveal very much. You can make them very specific. For example, the pricing service, you can make it so that only a specific reseller can get access to a certain pricing data, and he will not be able to get access to pricing from other that applies to other resellers. So there are some possibilities there of using the cloud to share data for sure. And this is something I think we'll see a lot more
of. Thanks for the interesting answer. So let's have a look at this one here. So what kind of 3D capabilities does Ace support?
Yes, now 3D is a pretty wide topic. We have a module on Ace that integrates into a CAD environment, allowing you to create rules that are linked to the CAD dimensions and parameters. And those rules can then be fed through and be exposed like any other model in these. But I think maybe the question comes about when you talk about 3D, we also sometimes look at visualizing the result, and as you're configuring it, either as you're configuring afterwards, you can see a 3D rendering of the configured product, and maybe within a scene. It can also be applications where you basically build up a system in a 3D environment. And for these scenarios, we have a strong partnership with Unity, and we have a standard integration to Unity products. We basically provide the configuration knowledge, and they, by the way, use exactly the same service, not surprisingly, as the one I've talked about. But they are then providing the visualization and the interaction with the user. So that would be an example, I probably should have put that on here, of yet another type of application sitting down here. Ace recently has support for what we call system level configuration. That is also very important when you want to build up a whole system consisting of many components that you bring in and need to combine to form a working system. So that's also a possibility. But from our perspective, being a platform, we just looked at that as just another usage of the same configuration service. So I think that shows some of the strength of this platform thinking, because when you build up a system with many components, you can certainly imagine that they come from different business units. They come maybe from sub-suppliers, and the application and the user who is actually building up the system in the 3D environment, he shouldn't need to know, and it should be completely sort of transparent whether they come from one source or the other. And that is what the platform will provide.
Thanks a lot for the interesting details. So looking at the time, so that's unfortunately all we have time for today.